In a previous segment, I had talked about solving for x and using that on a planar surface. However, I forgot to do a follow-up where we solve it on a more rounded situation. So what I'm going to do is press Q in HardOps and go under Mesh Tools, and we're just going to use Sphere Cast to turn this into a sphere. By looking at it from the front, we could press D and switch over to Box. And from here, activate dots. Because we're in dynamic dots, that means that we can get a dot perfectly in the center, not orient it to the surface of the mesh because we're starting off of the mesh. And by jumping off of this dot, we can just hold Alt in order to bring it out equally on all directions. And let's just extrude this back, and we're just going to press B to bevel, roll the wheel a couple of times till we get about 6 segments. And then from here, we're just going to rotate it till it's about 45 degrees. We can just click and apply, and from here I'm just going to press Alt X, and instead of bisect we're going to use modifier because this time I want to mirror it and actually get a realistic result. So here we've made a heart, and I will click once again, and we've made an X, and because it was beveled we got a nice rounded X. At this point I can still bring back the cutter and adjust the bevel for something a little more reasonable. However, I set it to the maximum, which is this, in order to give ourselves a more advanced solution to solve, because if we were to keep it mitigated to something small, we're actually only solving just this area of the surface, which would result in a rather quick video. So by having it go all the way around, we get to solve curvature and shading all the way around whenever we're dealing with this particular transition area, because it's going to be broken everywhere where it's not flat. But enough about that. If we press Alt V and we look at the wireframe, we can see that Booleans will do as Booleans will always do when it comes to giving results with geometry, and that is the most minimal of edges, just simplified based on your cutter. So I'm just going to Control A and Visual Geometry to Mesh, and because we actually cut this in the front of this shape, we're just going to divide our work by 4, accelerating this video. And so we'll press Alt X and bring up Mirror. We'll press D to switch to Bisect, but we want to use bisect and modifier. And from here I'm just going to shift click X, and then I'm going to click on Z, and basically now the only part left is this area here, which is what we're going to be resolving today. So whenever it comes to resolving an area like this, there's a couple of ways we can go about it. I'm going to save this file in Power Save as solve for X, and we'll save it, and it appears as the first of its kind, meaning the last solve for X did not get that same file name. Thank you, Power Save. But let's go ahead and get playing. So I was looking at this area just now and wondering, is that a cluster of vertices or is that just one vert? So it is a cluster. Let's just shift click mark, and instead of using select, we're going to use merge, and I'm just going to click and drag on this geometry. Even though it's very small, we see that it works with that one, but with this one it's a little bit more complex. So let's try it again. We select this edge and bring it to this area. We can select this edge and bring it to this area, but it looks like merge is going to let us do that today. So sometimes you got to just roll with the punches. I'm always saying that because, you know, the work on making tools is never done. There's always another bug to resolve, like the one we just mentioned. But with merge, you can always just click one point in order to choose where you want to send it, for example here to here. But if you hold shift, you can actually create a line in between, which is what I'm doing now to just create a little bit of guidance edge work. Drag to create that, create a loop across. Let's undo and shift click to create a loop. Let's create this area, bring these two together, but we want to Control Z and make sure we hold shift when we do it, because if we try to hold shift in the middle of the operation, it's just not going to work out. And so now we have another one of those areas. So it looks like for some reason areas on the mirror junction point are just not being picked up by select tool, so more likely we'll be back to talk about that. But let's press spacebar, and I'm going to press 2 in order to switch to edge, and we're just going to grab that and dissolve it. And because we're outside of select tool, we can just do a couple of things. I'm going to just draw an edge here to just bring this cluster together, meaning I can actually dissolve every other edge and begin my flow. And we see that our flow ends abruptly in this area. Select this point and this point to J lightning bolt, and we've now got our flow going just a little bit further. Let's join this one with J, Let's select these two, J, this one to J, these two, J. We'll select these two edges and dissolve them, and our flow goes just a little bit further. Wireframe mode by accident. And we see that our work gets just a little bit more complex as we get close to this corner. So we could possibly just leave it all ambiguous like we have it, but I do want this flow to go all the way to its destination. Even on the other side, we could click and turn this into a diamond quad situation, which would result in us having the flow that we want at the expense of an additional loop that's happening on the other side that's possibly going nowhere or actually going onto itself. So maybe we can leave it for now and just experiment and see how it treats us. I'm going to slide this area up, and GG to slide is one of my favorite things about Blender. Whenever it was added, I was quite happy about it, because sliding things is one of those operations that you do so much that you'll wish that GG existed. Just GG. You know, we don't always want to move geometry, we want to slide it. You know, as long as we slide it, we can keep our surface intact. And just like that, we've now solved for X with this particular area. So what about this area? Well, I'm going to press Shift tilde, which will give me my boundary selection, which can also be located here under Select Loops, Select Boundary Loop. And if we deselect these two loops, I can just Shift click Mark, and we can press B to add a perimeter bevel to protect this particular area, because we do want to protect what matters. And what matters is the geometry that's happening in these corners, and how we don't want subdivision to eat them alive by having a harsh transition whenever it comes to the edge. So here we are just quadrifying these areas. In this term, I'm just referring to us converting it to quads via hard work, not the method inside of Blender. I believe it's also called quadrify. And we'll place two loops here, grab them and connect. And because we're dealing with mirror and symmetry, we have a big convergence coming up in the center, so we want to be ready for it. And we could do that by reducing our loopage as we get closer to it, but let's think about this. Really, it doesn't even matter. I'm overthinking it. Let's just solve to the nearest points, and we are done. Like I said, overthinking. We could also Control R, add a loop cut on the real area of geometry, and slide it up to this area. And from here, our work is complete. If we press Alt V and we get out of the wireframe, we see that we were able to repair the surface with the most minor of surface damage done to the area as far as keeping the form together. So that's the point behind why you want to hand edges off to other edges and specifically slide things around the way you saw in the construction process of this, because if we just dissolve things willy-nilly without anything holding the integrity together, it would all just fall apart and we'd start dealing with lumps in the surface. But let's press Control 2 to add subdivision to this model, and we see that everything looks so far so good. However, Auto Smooth is still present. Let's turn Auto Smooth off, and now we can truly see what the result of our topological work was. And so this loop could be a little strict on the edge, so by sliding it off and sliding this one off, we see that we're able to get things a lot more rounded. So that's one of the things about subdivision is, love it or hate it, this is how you control your edges and their relationships with curvature and subdivision is how close they are to each other. So just sliding edges away from edges and reducing the thickness of your cluster will allow subdivision to grow more freely. So if we were to take this edge and dissolve it completely, we see that subdivision is unbound, but as we bring this in to tighten it, we could also get a very tight result. So we don't want to go too far with it because we're getting a larger subdivision rounding here, because we're sliding this geometry, which is actually a diamond quad. So we want to keep things as a diamond quad in this situation, and that is our result. However, before closing this video out, I do want to grab these edges and just press Control Numpad plus in order to grow, but we'll press B to de-box select this area, and we'll grow it again and just de-box select this, just because we want to definitely grab only the back And let's just slide it forward a little bit, just so a shallow X would maybe look better. But we also want to make sure we grab all the faces that we intend to move. So that was another thing with subdivision back in the day that would drive me crazy, is how in modifying it you would find yourself selecting large amounts of geometry and obscuring other pieces of geometry and specifically selecting the right thing in order to move it. Definitely not here to try to trash subdivision, but just one of those things about subdivision that I considered a bit of a nuance. You also might be noticing that I have triangles around the boundary of this, and you might be wondering how they would fare in the conversion with subdivision based on previous talks about it. So with any mesh, applying a single level of subdivision will turn everything into quads always. If we turn off optimal display and we press Alt V to turn on wireframe, we see what all of these areas solve into. So in order to give the amount of curvature that we need to these particular areas, these triangles will turn into basically self-containing loops that add density to these areas, but we see that everything is indeed quads, even though in the middle we're dealing with some rather skewed quads that I would probably try to get into something a little bit more box shaped. But just like that, we were able to quickly cut this shape into the side of the sphere, keep the form of the sphere, refine it to the level that we're able to add subdivision to it, and this was our result. So with that, I will end this video and I'll see you guys next time.